Good day, everyone. For this video, our focus is all about tricks in finding the higher order derivative. So let's have an example. Say we have a function given by x to the power of 5, e to the power of x, and you are asked to find the fourth order derivative of that function. So you need to perform derivative 4 times. And actually, if you are going to solve this one, it will be a little bit, the solution is a little bit long. So what we're gonna be doing here is you will just have to apply that trick. And the trick here is you just have to use the Pascal's triangle. So as you remember, since the exponent here is 4, so you have to end until the fifth line because the fifth line refers to the power of 4. 6, 4, 1. So that's the Pascal's triangle, and we will be using this one. So actually, it will be 1 plus 4 plus 6 plus 4 plus 1. So after that, next is this is your first function, this is your second function. First is you copy the first function here, you multiply x to the power of 5. Then you get the derivative of that function and you multiply it here. So it is just 5x to the power of 4. Then you get the derivative of the next function. This function, it becomes 20x to the power of 3. And you multiply the derivative again here. So it is 60x squared. You get the derivative of this, it becomes 120x. And next is for the second function this time. Let's change color into red. This time, it becomes, copy it here, e to the power of x. Then you take the derivative of that, and we know that the derivative of e to the x is just also e to the x, so you copy it here. Then you take the derivative again of here, so it will be e to the x again. And the same thing here, and the same thing here. And you just have to simplify your answer. Actually, if you simplify it, it becomes x to the power of 5 e to the power of x plus 20 x to the power of 4 e to the power of x plus 120x cubed e to the power of x plus 240 x squared e to the power of x plus 120x e to the power of x. Just simple as that. Okay, let us have one more example. Say, for example, we are given with, say, uh, say for example, we have x to the power of 6, then cosine of x, and you are asked to find the derivative of that 3 times, the third order derivative. So all you have to do is just 1, 2. Then for the third, so you will be having here 1 plus 3 plus 3 plus 1. And the first function, you copy it here, x to the power of 6. Next is you take the derivative of that, so it's 6x raised to the power of 5. Derivative of this again, so it will be 30x to the power of 4. Derivative of this, it becomes 120x to the power of 3. This time, for the second function, so it will be, you copy the first function first, cosine of x. You get the derivative of that. The derivative of cosine is just a negative sine of x. And you get the derivative of this again, so it becomes negative cosine of x. And the derivative of negative cosine is just a positive sign because the derivative of cosine is negative sign. Negative and negative, it becomes positive. So if you simplify it, it becomes x to the power of 6 sine of x plus 18 x to the power of 5 negative. It's negative, by the way. It's negative. Negative 18 x to the power of 5 cosine of x plus that is 90 x to the power of 4 negative rather negative as well, negative 90 x to the power of 4 sine of x plus 120 x cubed cosine of x. And that's it. That's the trick in finding the higher order derivative of a product.